All right, guys, so I ran out of data on my phone, which is fine. So we're starting over where we left off. So I think this is as far as you guys saw. And let's talk about the zeros that we've already identified so far. So we can set this x here equal to 0. That gives us a real zero of 0, zeros. So our zeros that we found so far are 0. And we can set this x minus 1 equal to 0. And that gives us 1. And now the question is, how can we factor this big polynomial down? So we've thought about grouping, but we actually don't see any patterns that are going to work for us. So we're going to need to use the rational root theorem again. So listing out possible rational roots, again in the form p over q. So factors of my constant go in the numerator. Those are plus or minus 1. And then factors of that leading coefficient, or of that leading term, are plus or minus 1 again. So we actually have the same options for our possible rational roots. So let's test out the easiest ones first. I'll write in red again. So p over q. Our coefficients in descending order are 1, -3, -5, and -1. So 1, -3, -5, and -1. So let's test out the root 1 first. So always drop down that 1. 1 plus -3 gives us -2. -2 plus -5 gives us -7. And -7 plus -1 gives us -8. So we don't have the remainder of 0 there. So this is not going to work out for us. So let's test out the possible root of -1. And hopefully that should give us 0 for a remainder. So drop down 1. -1 plus -3 gives us -4. +4 plus -5 gives -1. And then +1 plus -1 gives us 0, which is perfect. So now we can rewrite this big polynomial, factor down even more. So don't forget the x and the x minus 1. So now we can write p of x as x times x minus 1 times x plus 1. Remember, x minus a, and our a was -1. So x minus -1 is x plus 1. And then we can write our quotient. So this is our remainder of 0. The constant term is -1. The x term is -4. And the x squared term is 1. So we can write that as x squared minus 4x minus 1. So now we have a quadratic. So do we have two numbers that can multiply to -1 and add to -4? That's going to be tough. I would say use the quadratic formula here. So -b plus or minus the square root of b squared minus 4ac all over 2a. So now we're just plugging in numbers, where a is 1, b is -4, and c is -1. And we got that here from the 1 for a, -4 for b, and -1 for c. So let's just plug this a, b, and c in to the quadratic formula to get our other two roots. Because remember, we've actually found 3 roots now: 0, 1, and -1. So the fundamental theorem of algebra tells us because this originally was to the 5th power, we need 5 roots. And we actually only have 3 right now. So this quadratic formula should give us the other 2. It will give us the other 2. So let's start plugging in. -b is -4, so just 4, plus or minus the square root. So b squared, -4 squared is 16, minus 4 times a times c. So 4 times 1 times -1. So that ends up as minus -4. And this is all over 2a, which is 2. So let's simplify what's under this radical. So we have 4 plus or minus the square root of 20 all over 2. Okay, so we can simplify this radical again. So this is 4 plus or minus the square root of 5 times the square root of 4. We're breaking this 20 up into a product all over 2. And we can simplify the square root of 4. So we get 4 plus or minus 2. This is the square root of 4. 2 square roots of 5. And that's all over 2. So now we can break up this answer into 2 fractions, into 4 over 2 plus or minus 2 square roots of 5 over 2. You can break it up like this, or you can just divide the 4 and the 2 by 2, but you're going to get the same answer. So 4 over 2 is 2. And then these 2's cancel out. So you get 2 plus or minus the square root of 5. So what this does is this actually gives us our last 2 zeros. So our zeros are 0 from this x, 1 from x minus 1, negative 1 from x plus 1, and then the quadratic formula gave us the roots, or the zeros, 2 plus the square root of 5, and the conjugate pair, 2 minus the square root of 5. So this actually fits all of our rules. So we have 5 roots, 1, 2, 3, 4, 5, and we got our conjugate pair of 2 plus the square root of 5 and 2 minus the square root of 5. So now we have all of our zeros.